Hello and welcome. In this brief tutorial, I'm going to give you an introduction to Sefaira through SketchUp. You see here the home page. Sefaira can be accessed through SketchUp and through Revit. I'm going to give you a quick walkthrough using the Sefaira plugin for SketchUp. So you can see the homepage for the program here. It's a great early stage building performance modeling tool to assess energy and daylight. And what I've done here, I've opened up SketchUp. I've created a fairly generic 5-story office building. Could not tell you the exact window to wall ratio, but you can see the glazing proportion here is probably at or above 40% or thereabout. And if I were to just give you a quick little introduction to this structure, this model, what I have here, there's a building core in the middle. We have, it was designed with roughly 3 structural bays by 3 structural bays, about 30 feet per bay, so 90 by 90. We've got 15-foot floor to floor heights on floors 2 through 5. The first floor is slightly larger at 20 feet, and you can see the penthouse up here. So we have this building designed, but it's modeled in this particular instance here as an energy model in terms of the geometric complexity. Uh, this is not an architectural model. You can see here there's no depth to the envelope components. There's no articulation of any kind of architecture per se. This is just a very, very simple planar model. That's what Sefaira wants. That's what any early stage energy modeling tool really wants when you use a modeling program as a graphic front end to convey the geometry of your building to the energy modeling platform. Uh, Sefaira operates off of Energy Plus, and it also uses radiance for daylighting. In this particular instance here, you can see the only thing visible in my model is the geometry of the building itself. If I were to model other components, let's say a nearby structure, I could do that. It could be incorporated into solar access and therefore daylighting and energy assessment. But keep in mind that whatever you see in the model is going to be what Sefaira wants to grab and assess. So we have my model here. I'm actually going to give it, I'm going to zoom out a bit here and just suppose that I have, I'm going to say another nearby structure of no particular size here. I'm just going to create some kind of obstruction to solar access. So at certain times of the day, this building, actually in this particular case here, let me zoom around, zoom out. Let me actually select this and provide something that is actually going to be more of an obstruction. So I will put it here and let's just go ahead and make it a little smaller. But now we've got something that is going to um, present a bit of a solar obstruction for certain times late in the day. You can see that kind of listed here. All right, so we've got this. Let's go ahead and turn on our Sefaira plugin. Just going to bring up a menu that looks like this. And you can see here, it has not imported any information yet. I can hit update analysis. It will start to grab information. I'm actually going to put on here. Let's assume that this project, oh, it's in Boston. Yeah, that's good enough. You could actually type in any city that you wish. You could type in New York City and it would adjust for that. I'm gonna cancel this here. I'll keep it with Boston. We can actually, let's make it a little bit localized here. We'll make it Indianapolis. I'm just showing you, I'm just flexing a little bit here with the model. Uh, analytical capabilities. I can change it in real time like that. Okay, so I said Indianapolis, New York, Boston, take your pick. All right, so we'll hit update analysis. It's bringing in the geometry. It's thinking about everything, and it will start to do an assessment now. And we'll give it a second. It is actually running uh, up here at the top. Let me go ahead and cancel this. You want to set your analysis mode here. So notice it had daylighting by default. You could do energy by itself. You can make daylight and energy. Let's go ahead and keep it at energy. So now we'll update the analysis. You could tell by the dials there. That was what I immediately noticed. So now it's looking at Indianapolis, and it's going to go ahead and run this assessment. Okay, so it immediately brought in some information here. It was running Energy Plus off the cloud. Notice this caution sign to check my entities. So what the program did is it took what was visible and it made some determinations. It tried to make a first initial pass at what every surface represents in terms of a short list of um, envelope, interior, or otherwise noted forms here. So everything that's visible is going to be identified either as a roof, a wall, a floor, a shading device, fixed glazing, or operable glazing. You can imagine how those would play out differently in an energy model. Interior walls and interior glazing. This is important as well because those interior elements will come into play for daylighting, but they are adiabatic. They will not come into play for energy. And then things that you might want to ignore. If there are some things visible in the model that you don't want the energy model to examine, you can set those to ignore. So this is a good quality control check as you get ready to do your energy analysis. So I'm going to show the entity types and notice it gives a wash of everything here. And I'm glad that it did because while yes, this fixed glazing looks correct, it has my roof here and roof here. Notice this wall, but also look at this over here. Uh, it has that entire nearby structure that I just wanted from the standpoint of solar obstruction, and it has the entire thing listed as wall, roof. I imagine if I orbit here, yep, it thinks that the plane at the ground is a floor, so it's adding to my building. It basically thinks this is an extension of my project. So the very first thing I want to do here is select this, and you can just right click, go to plugin, set that as shading. So now that is adiabatic. It is not counting towards energy, but it will be counted as an element or collection of elements here that will obstruct solar access to the project. Now, I can dial these and look at each one and make sure that everything that's modeled here is in fact correct. So I'll hit roof. That would be correct now. I will click floor. It's got all 5 of my floors. It understands set your model at z equals 0. In Sefaira, anything that is negative in the z-axis, anything that's below z equals 0 will be counted as subgrade, as below grade, floor, walls, etc. So right now this is set at uh, z equals 0. So that's very important for modeling purposes. You can imagine the thermal differences when you have below grade walls versus above grade walls, etc. Okay. Speaking of walls, and notice I can dial multiple elements at once. So there are my walls. That looks okay. By the way, if the shadows get confusing, you can turn those off. Shading, that looks correct. Operable glazing, I should not have any. That's correct. Okay, and then fixed glazing, this office building has fixed glazing. Interior walls, so my building core have interior walls, and I don't believe I have any interior glazing. So there's also nothing on the ignore side. Notice it'll keep a number of how many surfaces are attributed to each one of these entity types. And you want to minimize the number of surfaces that Sefaira is going to examine. The more you have, the more the model is going to get bogged down. Again, this is an energy model from a geometric complexity standpoint. It is not meant to serve as an architectural model. So you don't need to put in individual mullions and all that sort of stuff unless it's extremely critical for daylighting. Okay, so we have this designed here. I'm actually going to zoom in a bit so you can see the building a little bit better. I'll orbit around so you can see this. Okay, so I am ready to run just an energy analysis. So we can actually hide the entity types. It'll take it back to the non-coded entities here. I can close my entity palette before I hit go. Next thing on the list here, office building. You can select from a very limited number of building types, each with their own unique set of assumptions and occupancy schedules and internal loads, et cetera, occupant densities, all those sorts of things. It's again, this is conceptual, so just pick the best fit. We already set the city. Uh, we have not set our enclosure properties yet, so you can click the model properties and notice here for this project, it has by default in this particular instance, 90.1 2019. There are some built-in standard baselines that you can set. You can see here, hash rate 90.1 2013. We've got some other standards. Um, I actually have built in already for a project in Indianapolis. I have ASHRAE 90.1 2007 office building in climate zone 5. That would be appropriate for the energy code that's currently in effect in the state of Indiana. So I will pick that. So we are looking at a building that has the thermal envelope properties of the prescriptive requirements set in ASHRAE 90.1 2007. So those are dialed here. Now you could go in and you could customize these. So I'm setting a baseline, but just by way of example, you can adjust your properties like wall insulation. Notice it'll give you this this black box that pops up to kind of give you a reference point if you're not familiar with it. So you might get down to something like infiltration rate. You're thinking to yourself, what would be normal practice? I'm not real familiar with CFM per square foot, for instance. You can look and this will give you something to tether off of. And if you had something like a passive house, you're going to be cranked way up over into this space, like 0.08 CFM per square foot. So infiltration rates in a really leaky building would be upwards of 1. Ventilation rates, likewise, you can dial these around. Your equipment, looking at watts per square foot in terms of equipment, uh, energy utilization, lighting power densities here. And what I've done now is made a big mess, so I can always go back, click back to my saved baseline. You can create your own baselines and save them as well if you work on a lot of projects in the same location or same typologies in the same location. But you notice it just brought everything back. I'll hit close, and I now have my building ready for a better analysis than what you see here. So in terms of better in terms of being more accurate for what I'm going to call here a energy code compliant spec office building in Indianapolis. So check analysis, it's going to run some numbers again, and it will adjust these two dials. This first one here would be the EUI, energy use intensity. So you can see the EUI number adjusting here. That EUI looks very generous. That's a very, very good building in terms of performance. My suspicion is I messed something up in here along the ways. But by way of example here, understand the smell test when you're working on projects. That 35 is, um, while it's not meeting the 2030 challenge, that's rather high in my book. I look over here at the distribution of energy segments, and I see it's primarily heating dominant. You can see cooling also a fairly big component, but lighting being big, and equipment fairly large here too, fans, pumps. You can see impact on heating, impact on cooling through this gains loss diagram here. This is always handy to look at. You can also include active gains and losses, and it will look at your building in terms of where this can give you a bit of a hint as to where the energy flow is happening on your project. And you can click over here into guidance. It taps into the 2030 palette. What I'm going to do here, this is where you can start to adjust things in real time. So it is considering the shading effect of that nearby structure that's coming into play. I'm going to say on my infiltration rate, that normal practice is probably fairly generous. Maybe we'll dial that back, something maybe around here. I'm just showing you how easy it is to dial some of this around. Lighting power density standard of 1. We're pretty efficient with our LEDs and such now. I could probably get to 85. Roof insulation, 20. Sure, I'll keep that there. Uh, Glazing assembly U factor here, that probably should be cranked up just a little bit more. Um, if it based on what I would probably use in a project today. Um, anyway, you get the sense of what's going on here. Wall insulation, crank that around. So uh, yeah, now I've varied from my baseline a bit. I'll close this. I'm actually going to do one more thing here. I'm going to show you not just the energy analysis, but I am going to turn on the daylighting analysis as well. And I'm going to run my analysis here and I'll explain that part of the plugin here. And then hopefully set you on your way. You should be up ready to fire up Sefaira and start using it. So uh, give it a second here. It's running a fresh Energy Plus analysis. You'll see these numbers change just a little bit, but then it'll also uh, refresh this third dial that's now been introduced. This is the daylighting dial. So give it a second here. That is finished. So my EY didn't change a whole lot. Still heating dominant. It's a mostly well-lit space. It's looking at percent of floor area with ample daylighting. This is a broad-based metric that's being offered here. You can see 31% of the floor being overlit. I would reckon with the proportionality and distribution of glazing area on this project that would be the case, but let's look at that a little bit further. Um, if I were to open the daylight visualization, notice that the view portal here is showing me the exact view that I have with the model right now. So if I want to change that a little bit, I can zoom in or out. I can try to center this a little bit so I can see it just a little bit better in the portal. So this looks pretty good. Okay. And now let's see here. I can try to adjust that just a little bit more. Okay, that's pretty good. Now let's look at what we have here. We can examine the day and time. You can set that. So I could set it for equinox. Sure, that would be fine. 9 a.m. That would be fine here. Sunny sky on a day. I'm actually going to set this. It's like there'd be a little bit more sun. I'll just say maybe 11 a.m. So let's just crank that up to 11 a.m. Okay, and I can look at this annual daylighting assessment. So I can hit update analysis. It will give me this. You can also look at overlit and underlit space, daylight factor, and direct sun. So I'm going to hit update, and it's going to look at my information here. It's going to give me a gradient based on this legend you see down here at the bottom of the view portal, percentage of occupied hours, where illuminance is at least 28 foot candles measured at a work plane height above the floor plate. You see that listed here. You can change this gradient to looking at it in terms of a grid if you wanted. You would have to update the analysis for it to reconceptualize that. You can isolate certain components of what's being visible so that you can perhaps study a little further, examine it. So now you can see here there's more of a grid, less of a nice smooth gradient. You can isolate certain floors. This can really help. You can very quickly turn them all back on. The context, you can turn off parts of your building. I could turn off my interior walls if I wanted. Anything, the shading device, that nearby shading device, if it was in the view portal here, you would see that fill up. So you can see how this would work. I'm going to set this. You can also look at contour lines. You can change the colors here. So in terms of getting the visual effect that you're looking for, So it's running the simulation again, running a radiance simulation. You can adjust that grid height as well. So if you like that gradient and this color scheme, if I go to overlit, underlit space, this is going to be more of a assertion. You can see there overlit being over, I'll just update this, over 93 foot candles of direct light for more than 250 occupied hours per year, and underlit would constitute that portion of the floor plate that has less than 28 foot candles for more than 50% of occupied hours, as it gives you that visualization. You can see here underlit, overlit, and as you look at each of the floor planes, you can see it also gives you your spatial daylight autonomy and architectural sunlight exposure. You can see with those two metrics, for the annual sunlight exposure here, we're not even close to hitting. I believe these levels here are in accordance with well building standard, and you can see and LEED as well, kind of common best practice, that you're not yet hitting your glare metrics where you want it here, with 10%, and the SDA though is looking fairly well. So what I might do actually is, in daylight factor 2, I'd be remiss if I didn't give you a quick look at that. Whoops. I'm just going to run that one here. So there's your daylight factor, and you can see that as the percentage of the floor area where the daylight factor is measured, and it's at that work plane height again. And you have all the visualization capabilities to adjust as we talked about before. One thing I think I might want to do is go back to the annual, and I'm going to set my day and time, and let's see if I can get a situation where, let's see, if I turn this to maybe late day, we knew that nearby obstruction, if I go back here, you can start to see, oops, trying to get that shading device to show up on here. There we go. So you can see that. And if I looked at annual, you can update that analysis. You can see that. Okay. And so now you can see here a little bit more intensity. That metric that we're looking at here in terms of how much ample daylight you get. You can start to see the effect now of this large nearby structure and the shading effect that it can cast in the building at certain times. Um, if I went to my overlit underlit space, you can update the analysis again. And once again here, it's going to look at our spatial daylight autonomy and our annual sunlight exposure, few metrics that LEED and WELL use. And I'm just going to try something here. If I were to go into the model, so this SDA at 86, ASC at 31, I'm going to try, if I zoom out, take away this structure, update the analysis. Let's just see if that has any kind of an effect. Now I'm just playing. I'm just seeing what this thing can do. But give me a chance to see how you can use this in real time. And you can imagine if you set shading devices outboard of your glazing areas and really fine tune that, you could start to control ASC and try to optimize SDA and ASC and really start to model a daylighting scheme in real time. I'm just a little curious to see how much that might change things, what kind of effect that could have. And so there, you saw the ASC metric particularly shift. You saw in terms of overall spatial daylight autonomy, it didn't change much, but the annual sunlight exposure did worsen when you lose the shading effect, and that's the result in more glare. You can see uh, how much more is over in this corner of the building that was near that shading device. So this is where you can really start to investigate daylighting and energy, uh, how much daylight autonomy you have versus glare, and really start to make a comprehensive uh, concept design that's going to try to optimize energy and daylight. So uh, this is your basic run through of the Sefaira plugin in SketchUp. I hope this is helpful and happy modeling.